Here we're going to look at what is required to get achieved in our linear programming standard, looking at this task about surfboards. So what we've got here, this is an example of what your assessment will look like. There'll be a whole lot of information that you need to interpret. First off, read through all of it really carefully. And then the first thing to think about is, what am I going to choose to be X and Y? My first sentence, a company produces surfboards in two types, rider and performer. And later on it said, it asked me, the question overall is to find the maximum profit that can be made per month. And that is based off $40 per rider board and $50 per performer board. Well, I'd need to know how many of each of those boards to get the total profit. So that's what I'm going to be labeling as X and Y. This next part here with the numbers through it, that's going to help me write my inequations. And then this part where it says profit and maximum profit, that's making me think, this information is going to be used in my objective function. This last bit where it talks about something new or changes or a new company, something's different, that part is relevant for merit and excellence, so we won't look at that just here. But below, this is an example of how you'll write this out. Let X represent the number of rider boards, let Y represent the number of performer boards. And you want to be specific there, not just say let X represent rider boards. What about the rider boards? Is it the cost? In this case, it's the number of each of our boards. Next, we've got our inequations. So this first one came from, in the information above, it said that they had to make at least 40 rider boards. So the number of rider boards has to be greater than or equal to 40. Similar for performer boards, they had to make at least 60. My third inequation, this came from the maximum number of boards that they could make. So the rider boards plus the number of performer boards has to be less than or equal to 200. They could make a max of 200 boards. This last one comes from the cost of making each of them. So it said it was $60 per rider board and $80 per performer board. And that had to come under the budget of $14,400. Next is my objective function. This was the profit that each of the boards made. I'm ready now to write out my equations to pop them into Desmos. What I've got here, these inequalities, they're exactly the same as what I've got up here, but the sign has been switched around so Desmos colours out the right thing. So make sure each of those signs are changed and then really carefully copy them into Desmos like I've done here. And your graph should look like this. You'll want to screenshot that part and bring it back into your task and clearly label the feasible region. So that's that blank space in the middle. Then we're going to go back to Desmos to help us get coordinates for our table. So in Desmos, you can click on a line and then you'll be able to hover over the corner points. You can, if you want, click on that and that will leave them up there so you can see them and copy them out. Make sure that you get every single one of those vertices from your feasible region and pop them into your table. Doesn't matter what order they go in your table, just make sure they're all there. Then our working is going to be our objective function, but we're going to have to swap out our X value. So in this first one, 40, and our Y value, 60. So we've done 40 times 40 plus 50 times 60 for our first one. Do all of those on your calculator and you'll get the profits down here on the right. The question, remember, was asking us what is the maximum profit. So we're looking for the biggest number here. This is at 9,200. So I'm interested in that and the coordinate over here that matches it. We've got to write that out in a sentence here. So the company should make 80 rider boards and 120 performer boards to get the maximum profit of $9,200. If you can do up to there, then you've got achieved.